Good afternoon. Welcome to our afternoon insight sessions. To start off, we've got Vega Australia, who are here to talk about the 80 gigahertz radar level transmitter technology. And we've got John Leadbetter, who's the Managing Director of Vega Australia, here to present to us today. So welcome, John.
Afternoon, everyone. I'm John Leadbetter, as Sean said. What I'm going to do is we've got quite a few slides, so I'll go through pretty quickly. We are time constrained, something from there. So for those who aren't aware, Vega is a German manufacturing instrumentation company. So one of our heavy industries is mining in Australia. We believe the future of mining is in two areas for us. One is instrumentation development, the other one is adaptation to IoT4. In regards to instrumentation, radar level transmitters have been on the market now a number of years. What we've done now is develop the 80 gigahertz model, so the thing from there, which is our latest generation of liquid and solid radar level transmitters. These are the sort of things that we picked up in the past that were sort of not faults but challenges. So we looked at all of these particular feedbacks and said, right, we need to develop something that's going to overcome some of these obstacles. So, principle of radar, as your frequency goes up, your actual antenna size comes down. The natural outcome from there is you end up with a narrower, more focused beam angle. So traditionally in 26 gigahertz, you had a fitting of 1.5 inch, or DN50, you ended up with a 20 or 15 degree beam angle. Now that we're bringing the actual antenna down to a 3/4 inch, you actually end up with a 14 degree beam angle. The larger you make that process connection or antenna, the narrower your beam. So therefore you're able to get around a lot of obstacles, such as agitators inside vessels. You're actually able now to focus on your real level rather than picking up the echoes from the agitators. So if you look at a live example here from a crushing circuit, traditionally on the left was the 26 gigahertz model that had an 8 degree beam angle, had problems with picking up interference from the chambers, from there giving false readings and giving a slow response. On the right we developed the 80 gigahertz, narrow beam angle, able to focus down the throat, giving you much more reliable signal, faster response. So traditionally we had 96 decibels of dynamic range or energy from the system itself. With the development of our 80 gigahertz, you've now increased that by 200 times, or 24 decibels. So we're getting a much stronger signal back, so when we've got a lower or less conductive product, we're actually getting a better return of signal. So traditionally in an application for 26 gigahertz, you would send down your transmission and you would pick up off low dielectric materials a very small echo. You change that over now to the higher range unit, send down your signal, and you're getting a much higher signal return, so therefore you're getting a much stronger, more reliable signal from your materials. Live example there, looking at a low dielectric material. The one above is our old 26 gigahertz, the one below is our 80. As you can see down there at the 25 metre mark, we're actually able to pick up that material. So that could be a lime silo, could be a low dielectric material. Again, with 26 gigahertz, build up inside the vessel itself. If that's inside the beam angle, it's going to see that build up. Those build ups can create false echoes, which means you get false readings. And the more build up you have, the worse it gets. As you shift over to the narrower beams, you're getting a much stronger signal. You're not seeing the sides of the vessels. You're not picking up any build up. One signal, one return. In comparison there. Build up, as in this, showing here on a bitumen tank, where you've got bitumen on the face. You're not able to see that bitumen, therefore you're not getting a reflection from it or blocking the signals. We don't control how people install the units, but in these cases here, they're installed in large standoffs. So I think from there, traditionally what would happen in these sort of areas is that you'd end up with a lot of ringing inside that tube before it actually came down and read the real level. Again, you've got so many different zones that it's focusing on, it ends up losing the signal. Change it over to the 80 gigahertz frequency. We're not seeing anything inside the standoffs, and all the echo that we're getting is the one echo from the material itself, much stronger, much more reliable. $700mm socket here, one single echo coming back, no interference. Lock-off valves, again the same problem, is that you're going to get a lot of ringing inside the valve stems themselves. from there, creating really a situation of you don't even know which is the real echo anymore. Again, by going through and changing over to a high frequency, you're able to get around those issues. You're not picking up those ringing echoes. You've got a much more reliable signal coming back, as in the example there. Moving into another part is differential pressure. In differential pressure, we again looked at feedback, and we're able to now give a much more sort of more precise type of instrument now. Bluetooth technology is something that the future is holding. We've been doing it now for about 2 years. Communication through smartphones, iPads, tablets. From there, single chamber EXD, SIL approvals, and you get your measured value and an event memory, in other words, asset management. What you're also getting out of there is you're getting 2 outputs, one for your differential pressure and one for your static pressure. So you can have them as 2 separate outputs, faster response times, improvement to accuracies. So again, development of a technology by getting more out of the technology from there. Bluetooth, as I said, Bluetooth devices now, so things from there across the transmitters. In an EXD environment, you're actually able to operate this through the glass lid, where you can actually do the programming with a magnetic pen. So therefore you don't require to go in there with and break the integrity of the EX area. It can be done via a laptop, communication, Bluetooth 4, communicating directly to the instrument, roughly about 20 to 25 metre range. It can be done through a smartphone or a tablet. The apps are downloadable from the app stores, from there they're free of charge, and you just communicate through and away you go. Industry 4. Okay, traditionally what we've looked at with Industry 4 is there been the 4 stages of industry development from 1784 right through to today, from there. So we've looked at the fact that you've got all your different levels of communication and management. What we've had to do here is look at the fact that everybody has access to the same information. From there, so through a cloud service. So traditionally it's been done through HART, Profibus, Bluetooth communications from there. In the signal conditioning through Ethernet or Modbus. Future which we're under development now is for Profinet and OPC UA. So these are currently under development from there. If we look at mobile communication through the networks, okay, GSM, GPRS are all available from there, or through the router systems, Wi-Fi, Internet, Ethernet, sorry, Bluetooth. Again, under development, and again, heading towards 5G networks. So traditionally with Bluetooth communication, it's a case of accessing the information so that you can keep maintenance, stability, everything like that with your instrumentation. So this is a communication, not an output, using this type of system. The development now through a Bluetooth gateway where that information can be uploaded to the cloud, and then you can access that information from the cloud. It can be displayed remotely. So it is a case of developing Bluetooth now more as a communication path, as an output path, as well as a communication path from there. Wi-Fi networks, hardwired networks, all go up into the cloud, and that information can be accessed remotely. Okay, again with Bluetooth, up through the gateway into the Vega cloud, and that can be accessed by third-party systems. So again, development towards third-party access through SAP, OPC UA, where you're able to access your own information from there and control your network and your instrumentation. Okay, so that's briefly it. We're over on stand 17, I know as a brief overview. If anybody wants to come across and actually see the units demonstrated in those types of applications or the communications, by all means feel free. Any questions? Nice. Thank you.
Thanks very much, John. And as John said, the Vega stand is just out the door to the left, so the guys there are happy to answer any questions you might have. Our next presenter is Uptake, and they're here to tell us about how to accelerate outcomes from the digital mine. And we have the Director of Manufacturing and Mining, Ashutosh Agarwal. So welcome. Thank you.
guys. I'm actually Alvaro Leso. I'm a pre-sales engineer at Uptake too. Ash couldn't make it right now. So a little bit about Uptake. Uptake is a predictive analytics company. Whoa. Sorry about that. So Uptake is a predictive analytics company, and actually one of the last slides showed by Vega came out really handy. Actually, what we do is adding that next layer that integrated all the data sources coming from your company, and we run analytics and machine learning algorithms on top of that data in order to get and to deliver financial outcomes. In this case, I'm going to talk about a particular case of a project we did in Chile, working on a SAG mill, and actually what we did, we ingested data coming from the machine, from ERP systems from this company, and we were able to give insights around liner wear and liner life extension. And the way we surface those insights is through an application similar to what we're seeing right now on the screen. So we've heard throughout this conference about the cultural changes, about pushing the next step in innovation to the people that are actually operating the machines. And we feel like the best way to do that is through an intuitive application that can serve anybody throughout the organization. So what we're seeing right now is a quick dashboard of how this plan is running, what are the main KPIs that need to be addressed, what are the real-time outcomes that this plan is delivering. We can see production rates, how am I doing next to the thresholds I've set up, next to the objectives that I have as a company. I can have a quick view of the sectors of my plant, and actually I can go a little bit down and have a look of, okay, of the 30 whole trucks that I have, 3 are retained, 4 are down. But what I really see, it's a problem in the SAG mill, right? I see that I have only 1, and the health status of that machine is not ideal. I actually have a problem there. So I want to go deep, and this is the moment where the VP of Ops picks up the phone and say, hey, I want to talk with the maintenance manager that is in charge of this concentration plant, and I want to drive my discussions around the SAG mill. I can see that I have a few bilge pumps, but I know that in a forward-looking approach to maintenance, I can see that this SAG mill is at risk. So I click there, and again, I have a quick view of how my asset is running. If I'm getting the KPIs that I've set up for that asset, what's the throughput, what has the history been for this asset in the past week, the past month. This is highly configurable. I can show up whatever KPI is important for me, or whatever information I can surface from different systems, from ERP, such as SAP or Oracle. I can bring data coming from condition monitoring system, vibration data. We're going to see that in a second. And I can monitor, in this case, the customer was interested in monitoring liner wear. It was a big expense for them to do the 3D scans and actually deciding when was the right time to change the liner. So one of the things we did for them is helping them out with their plant maintenance strategy. And by doing this, we leverage a huge library that Uptake has recently acquired from the energy, nuclear, and manufacturing space, called the Asset Strategy Library. And basically, this strategy library is around 800 assets and all the different failure modes in which those assets can fail. So we were seeing, by looking at SAP data, that the most important failure contributors that we needed to attack was clogged cabinet fan in the refrigeration unit, misadjusted interlocks. And by leveraging this asset strategy library, we were able to say, look, if you change your frequency of your PMs into this order, you're actually saving around 10,000 K from what your OEM is recommending. And we all know, we all have a car, and we all know that the OEMs recommend excessive plant maintenance activities. But actually, I can go from looking at data coming from the machine, what's the speed, and this is when it gets really interesting, and you can have actual machine learning algorithms that can actually that are able to detect anomalies or predict failures. In this case, our model was looking at different sources of data coming from the machine, from RPM, torque, amount of water that the machine was handling, the size of the balls inside the sag mill, and eventually one of the most important readings that we're having was the oil pressure at the pockets of the machine. And by looking at all these signals simultaneously, we were able to detect multivariate anomalous behavior and give an insight to this customer in saying, hey, we think that this liner will have a high chance of wearing out in about a week. So it's about time you have an inspection made and get your maintenance team working to change that. So what's really interesting about this is actually from this tool, you can go and take action on it. And so you can go and create a task. This will push the information to your ERP system, to your SAP, to your Maximo. And once you do that, the beauty of this is actually by looking at past data, you can pre-populate a work order data, and that will save time and will save data entry errors from your technicians. When you go and you submit a task, you would actually create a plan, an action plan for this activity. And when you go and see what are the tasks that I have opened for this plant, I can actually see the last one I created for the sag mill. When I go there, I can actually see who's the owner of this task, so I can manage ERP data and ERP work order task from the same application that I'm getting the insights. And I can always relate that activity to the fault that I just got from a predictive model. So this is a way that we're helping companies kind of move from a reactive approach to maintenance to a more of a proactive approach to maintenance. And we see that this is not always the way to go, right? Sometimes numbers don't make sense, and we don't want to instrument a machine just for the sake of it. So we help companies across that way. From reliability center, just by looking at historical data and relating the data that we see from historical information to the failure modes that are being mitigated, to a more of a condition-based approach in which we detect anomalies from the signals we're receiving. And eventually what we want to do is relate those anomalies to failures that we see in SAP or something like that. So eventually what we would do is whatever signature that we can see in the data, we can say, hey, there's a high likelihood that this equipment is going to fail in 2 weeks. This is just a sample of one of the applications that we have. For mining, we work with haul trucks. We have around 20 models for haul trucks. From equipment failure, concrete equipment failure, but we also have models around oil analysis where we can see trends and give prescriptions about what may fail, what may work inadequately. But also we're leveraging our asset strategy library to help in this transition from reactive to proactive for fixed assets. So we've seen crusher mills, we've seen sag mills, we've seen slurry pumps, we've seen reciprocating compressors, other types of compressors. So this has been a very brief introduction or showing off how an application can help out. But we invite you to come to our booth and learn more about what we can do and what we've done in the space. Thank you very much.
Thanks very much, Alvaro. We'll go straight to our next session. This is the last Insight stage for the day. And the next presenter is Ben Smith. Ben's the Director and Mining Engineer of Conveyor Manufacturers Australia. And Ben's here to talk about actually innovating because of the need, not just because we can. So welcome, Ben. Thank you.
Very good. Thanks, everyone. We never set out to design equipment. I set out to design a process and to fix a problem. I'm a bit of a fan of the Toyota production system and lean manufacturing, and they talk about removing waste. So we sat down and said, right, what are some of the biggest wastes that we have in a mining process? And in its most fundamental level, the one I came up with was time. But it's the only one you can't get back. You can buy more gear, you can get more people, get more capital, whatever it is, but once time's gone, it's gone. You might think you can make it up, but you don't really. That's just an opportunity cost for later on. These are two of the most annoying icons or graphics that I ever look at. And to me, that's complete and utter waste of time. It's inefficient, we're waiting around and nothing's happening. My past, I started as a coal miner underground and I guess worked my way out of the mine, so to speak, became a mine manager and whatever. And these were some of the sentences that we used to get all the time. Oh, I've always done it this way, or can't we just keep life simple? Why do you want to have to unpack everything all the time? My mining nickname is Sparrow, probably because they flit around with too much energy, not achieving too much, but it's certainly frustrating. So the first area, and my background is predominantly underground, was a typical underground coal mine. And when I sat and looked at it, we take the most amount of jobs, the most amount of people, the highest risk activities, the most amount of mobile and diesel equipment, and we stick it in the most congested part of the pit, and we expect it to perform. And then when it doesn't, we all sit together the next day and we scratch our heads and look at each other and go, oh, okay, we'll do it better next time. But we do it every time as if it's the first time we've ever done it, and it doesn't improve. And you come to conferences like this, and we talk about the same sort of stuff. So we decided to look at it from a process point of view, not from an equipment point of view. Process isn't nearly as sexy or exciting as looking at new equipment. So basically what we did is we took as many of those tasks and as many of those jobs that are typically done at the in-by end, and we moved them out. So the guys and girls at the face, they are there to cut coal, and that's it. All of those other jobs, wherever possible, get taken out and divorced from the process. This was a mine that I was loosely associated with, thank God I wasn't the manager, but that's how they managed their conveyor structure. Came out from underground, was tipped in a pile, guys at $70 an hour on overtime, spent all shift sorting through it, and paid a contractor $3 million a year to drive out from town to pick it up, fix it, straighten it, clean it, and send it back to the pit. And ultimately, conveyors, whereas I guess the bit of equipment we chose, have not really changed forever. It's still a big rubber band rolling along on idlers. So we decided to do something about that, and certainly in an underground mine and in a different set of circumstances for an open cut, there is a hell of a lot of lost time. We tend to look at the major delays that we report, but it's a little bit like an iceberg. There's a whole lot of inefficiency that we have built into our processes that we don't measure. We just accept that, well, that's mining and that's just part of it. So there's this artificial glass ceiling that we've imposed on ourselves, and we're trying to break that. So red line is our first system, I guess, in solving this. There's some major components to it, but essentially it is like a normal underground conveyor, so it's not like a mine has to go and repurpose their whole operation. They can use a lot of what they already have, but there's some IP in some of the components that we've designed. Essentially, rather than the conveyor being a fixed bit of equipment that's either hung from the roadway roof or mounted on the floor, it drives along a monorail that's hung from the roof. And by that, and multiples of them together, the system can drive along the monorail and operate as one continuous conveyor. So rather than having to extend it and make it longer or shorter, which is a normal part of the mining process, at the in-by end, which ultimately stops production, we can do that from the out-by end without stopping production. So all of that time is brought back. There's a hell of a lot of manual handling and other safety and cost benefits as well, but really the extra production time is the big one. There's a height adjustment mechanism as shown there, so you can grade the belt up and down. They say the simple ideas are often the best. The height adjustment mechanism isn't too dissimilar from a Hills hoist, the clothesline. We were living here in Sydney, and I was teaching the kids to swing around on the line, and I fell against the handle, and yeah, that was the solution. Simple, but it works. The rollover idler is a second bit of equipment that we've come up with, and this allows idlers to be changed on a conveyor without having to stop it. So it's not just for our underground conveyor, but any surface conveyor in any other industry. The whole idea, rather than a lot of systems where you have to reach into the conveyor and install something to lift the belt up off the idler that's failed, the idea is that the idler comes away from the conveyor and the conveyor stays as it is. But it's replaced and removed and changed from the safety of a walkway or away from the operating conveyor. This is a pretty image, I guess, of the installation recovery centre where we make the conveyor longer and shorter. So this is out by in the panel, so away from the production area. And from that point in, so up the page, the conveyor drives along that monorail and operates as a full, complete system. And the reverse during production when the conveyor is coming back out. Some more pretty pictures of a typical underground mine. And that's the rollover idler in its rolled over position, I guess you could say. So in terms of what's the impact for a company, pretty significant. We ran a model last week for a client that we're discussing with, and on their operation, they expect to be able to cut about 25% more coal a year without any extra expense. So it is a significant amount of money. And at the moment, coal price, depending on the product or whatever, can be several $100 million a year. So needless to say, they're fairly interested. Or in the other part of the cycle where prices aren't as high, you can reduce costs. Our other system is a container conveyor. This is more aimed at surface power generation, ports, open cut mines, that sort of thing, and certainly not just coal. The container conveyor really is designed to fix the problem of fixed infrastructure. So at the moment, conveyors are regarded as fixed assets. Once they're in place, they're there. They're concreted into the ground, they're built by hand. You can't really recover them, and if you do, they're not really worth much, and they cost a hell of a lot of money to move. And certainly in New South Wales, regulators are now making you fully rehabilitate the prior site, so you can't just bury them like we used to. They've actually got to be physically taken away and disposed of. So how do we do it? It's the humble shipping container. So the shipping container is fitted out with the conveyor at our manufacturing facility, and it arrives to site in a plug-and-play format. So any options that you choose, be it pipes, cables, lighting, fire suppression, whatever, walkways, is all fitted out prior to arriving at site. So it is a registered shipping container. It is transported to site as a shipping container and then becomes its operational framework, I guess. We can span up to 2 modules at the moment, so 80 feet between foundations, so perfect for gantries and that sort of thing. We're working on a major international airport at the moment with this system, and it had to be fully enclosed because they're transporting fly ash and cement powder, and this is essentially a view of the system that they're looking at obtaining. The sides of the container are able to fold out if you want, and to provide an external walkway, which can be fully covered. Very, very simple. There's no rocket science in any of it. There's a hell of a lot of engineering in it, but there's nothing tricky about it. But again, it's trying to address those fundamentals of time. So in this instance, the time to install an overland conveyor is usually fairly significant, and operators will want to truck product or truck material while the conveyor is being built. Because it takes so long, and usually where they are, they cost a hell of a lot. These being modular, you can pick them up and reuse them very, very inexpensively. They're the first 2 modules being built overseas. And as I said, there's really not a hell of a lot to them. It's a fairly simple concept, but I think that's what people like. That's me. Any questions? Yeah, sure.
Really enjoyed your presentation.
Thank you.
The container ware, it seems to me, after you put the modules together, putting the conveyor is more work than the traditional.
No, it's the same. It's just pulled along.
Rubber?
Pulled along
How
was
do you
normal.
do it? You do from one end to the other.
Just a winch
Is that
as
how
you
it's
install.
done in the regular?
Yeah, yeah. Our other version, every module is its own conveyor system. So you could go around right angles or up steep gradients or around an obstacle or whatever. So like a cascading system.
So this design will make it easily. You can move it from one location to another.
Absolutely. Yeah, absolutely. So there's an operation in WA we're talking about. They buy a new conveyor every 2 years because their pit moves so fast and because they're not worth anything to recover. This, they will only have to buy 2 for the rest of their life of mine. And they just leapfrog them.
One more question. I mean, I know that conveyors are known for safety concerns. And the part that you show in the underground mine, you can continue operating and it just worries me. It's going to be some safety concern there.
The whole point is that you can do it away from the conveyor. Some companies will choose not to touch a moving conveyor at all, no problem. But even so, with that system, the time taken to replace a failed component, or even just wind it away from the belt so that it's not going to cause any damage, is a significant improvement from now. Yep. And combined with monitoring, it's perfect. Yep. Cool. Thanks.
Thanks very much, Ben. And just a reminder that all the presentations you've seen today as part of the Insight stage are available online as on-demand videos. So if you go to Australia's Mining Monthly, you'll find them there as a resource for the industry to learn from. That's our last presentation for this room today. You're welcome to go next door, and we'll have 2 more sessions before we close for drinks and networking. Thank you.